Hi everyone. In this mini lecture, I'm going to be talking about how to solve a problem that should help you with number 6 on the second exam. So in this case, what you're trying to do is you're trying to define a function that you give it a string s and you give it an integer n, positive integer n, as inputs, and it will find the nth vowel in the string s. That will be what its output is, right? So for example, if n is 5 and s is the string, the quick brown fox jumped over the lazy river, it's going to try to find the fifth vowel in this string, which is this second O right here. So just some assumption we're going to make. We're going to assume that the input s, so the string that we give it, has at least that many vowels, right? It has at least n vowels. So when n is 5, we're going to assume it has at least 5 vowels, right? Okay, so how do we go about doing this? Well, just like many of these problems where we're scanning through a string, right, we're going to need to keep track of the position we're up to, right? So that's going to be our item, right? And our item could potentially go, we're going to start it at the beginning of the list, so we're going to start the position at 0 all the way up to, we're going to potentially go up all the way to the last character, which is at s.length minus 1. So remember, range, we have to give it one more, so we stop it at s.length minus 1 plus 1, or just s.length, right? So so we do have to keep track of the position, because you can imagine if you were doing this yourself, trying to find the fifth vowel, you'd maybe put your finger over the characters that you're currently at, right, as you're scanning the string, trying to find the fifth vowel. So putting your finger there is like equivalent to sort of keeping track of what position you're at, right? So that's going to be what our item is. Our accumulator, you have to think of what else we're keeping track of here. Well, if we're trying to find the fifth vowel, right, we're probably counting vowels as we go along, right? So, you might do this subconsciously, but you're like, as you're scanning the string, you're asking, oh, is this T a vowel? No, it's not. Okay, so I've still only seen 0 vowels, right? You start at 0 vowels. You haven't seen any yet. You say, is the T a vowel? No, it's not. Okay, so it's still 0. Is the H a vowel? No, it's not. So it's still 0. Is the E a vowel? Yes, it is. So now we're at 1. Is the space a vowel? You might not even ask that, but in this case, again, it's not. So we're still at 1. Is the Q a vowel? No, it's not. So we're still at 1. Is the U a vowel? Yes. Okay, so count one more. Okay, so now we're at 2. Okay, is the I a vowel? Yes. Okay, so count one more. Now we're at 3. Is the C a vowel? No. So we're still at C, right? And you keep going, and then you count the fourth O, and then finally when you count the fifth O, you say, okay, I'm done, right? I found the fifth vowel. Right? So what I was trying to illustrate there is what you were keeping track of to find the fifth vowel is the count of how many vowels you've seen to that point. Right? So remember what I said, that with all these types of problems, you really want to draw the table first, and you want to know the relationship between the accumulator and the item. Right? So let's try to draw this, and we'll also fill in the code. So I'm going to copy and paste this here, and you should always be checking your code, running it to see if it produces the output that you expect. But before I even do this, as I said, I want to draw this table here. So I'm just going to do it over here. We have our accumulator and our item, right? Now remember that our accumulator, the first row, first column, is whatever we're going to put here, right? Now when you have to fill this in, you would say, okay, what should my starting accumulator be, right? And we talked in previous problems, for sum, you would want to start it at 0. For product, you'd want to start it at 1. Again, assuming this is an empty sum or an empty product. Well, for the count, right, you'd also want to start it at 0. Right? You haven't counted any vowels, right? So that's why we put the 0 there. But this tells us what we're going to put in first row, first column of our table. Okay, so the item, remember, is going to be whatever the starting number is here. So the starting number of the array, so that's going to be 0, right? And what should be the relationship between the accumulator and the item, which the item here being your current index or your position? Well, here again, it makes sense that we said that the accumulator is the number of vowels we've counted so far, right? So we started the accumulator at 0 because before we've even looked at any letters yet, right? So we're looking at how many vowels are there before position 0. Before we even started looking at any letters yet, we say the count should start at 0, right? Again, if it makes sense to start the count at 0, maybe some other problems, you're not sure what to start the accumulator at, but we talked about a way how you would think about that, right? So like product, we said that you'd want to start it at 1 because you're going to be multiplying numbers each time. And when you have that first number, if you have that first number, let's say of 5, you want the accumulator to be 5. But if you're multiplying numbers and you were to start the accumulator, let's say at 0, you would be multiplying 0 by 5. So instead of having an accumulator of 5, which should be the product of one number 5, you would have 0 times 5 or 0. And if you started at, let's say, 2, right, instead of having that product of 5, you would have 2 times 5 is 10, right? So we defined it to be 1 because that would just work out where if you did 1 times 5, you would just get 5, which is the number you would want to start with once you actually saw one item in the list, right? So here we're going to want to start it at 0 because what we're going to be seeing is that when we, that first vowel that we see, we would want it to be 1. And what are we going to do each time we see a vowel? We're going to be adding 1, right? So it makes sense that we would start it at 0, right? But we're not always going to be adding 1. It's going to depend upon whether that character is a vowel or not. Okay, so I'm getting a little ahead of myself, but let me continue drawing the table here. So let's assume we're dealing with the quick brown fox. I'm just going to do a little of the table, not the whole thing, just enough so you can see what the pattern is, right? So we said again, the accumulator should be the number of vowels that we have before the character at that position. So we're seeing the number of vowels before the character at position 0, which for this input of S, the quick brown fox jumped over the lazy river. We're looking at the ones, right, in this case, before position 0, there are no characters, right? That would be true for any string. So if there are no characters, there are no vowels. So we started the accumulator at 0. But when we have an item of 1, right, which is going to be our next one in our range, right, when we were looking for the number of characters before position 1, the number of vowels before position 1, we're going to say, oh, there's still 0 vowels, right? That T was not a vowel, right? So we'll keep the accumulator at 0. Okay, so then we go over to the next character at position 2, right? And again, we're still looking at the characters before this one, right? We've actually, when we have our cursor here on the E, it means that we just looked at the H and the T previously. So again, our accumulator is still 0 when item is 2. But when item is 3, right, the accumulator becomes 1 because now we're saying how many vowels are before the character at position 3, which is the space, right? And you see that you have that E there, right? So again, the item is basically the way we're setting up this table. You don't have to set it up this way, but the way we're setting up this table, the item represents the character that we're up to, but we haven't actually looked at yet, right? So again, now when we have the item of 4, right, it says, okay, we've looked at characters 0, 1, 2, and 3. So in particular here, we just saw that the space was not a vowel, so it stayed at 1, right? And then we go to 5, right? So now we've looked at the first 4 characters. sorry, the first 5 characters, but characters 0 through 4. And again, the Q in this case is not a vowel, so the accumulator still stays at 1. Right, I'll just do a couple more here. So now we're at 0, 1, 2, 3, 4, 5, right? So we're at this 5th character. We're moving on to 6. So once we saw this U, we would say, okay, now we've actually have 2 vowels before the I. Right, so before position 6, and then when we go to the C, okay, we've looked, before position 7, right, because that's what the C's at. And our count just went up 1 again because we saw the I, right, etc. Right. So the point is, when we're setting up this, right, we're defining this function and figuring out what to plug in, we're looking at this table, right? So remember what I said is that you have to think for what you're going to be repeating, you have to think about what you're doing with the accumulator, right, and the current index of a given row to get to the next row, right? So you notice sometimes the accumulator's just staying the same, and sometimes it's going up 1, right? So it's not always the same thing, right? Whether it goes up 1 or not depends on the condition, right? Specifically, it depends on whether the character we just looked at is a vowel, right? So, like if right now, if we say there are, over here, this represents that there are there's 1 vowel before position 5. So if there's 1 vowel before position 5 and we want to know how many vowels there are before position 6, we have to look at the character at position 5 and determine whether that's a vowel, right? So if it is a vowel, which in this case it is, right? 0, 1, 2, 3, 4, 5, that's the U. Then we want to say, okay, there was 1 vowel before position 5. The character at position 5 is a vowel. So now there are 2 vowels before position 6. The number of vowels there were before position 5 plus the number of vowels, either 0 or 1, at position 5, right? So we're really just adding 1. And we need to ask if the character at that position, if S of current index, right? That's the way of getting the character of S at current index. If that's a vowel, then we want to take the accumulator and add 1, right? And otherwise, right, so if we had another situation where we were, let's say, at index 4, right? So we say, oh, there's 1 vowel before position 4, 0, 1, 2, 3, 4, right? That was the Q. And then we say, how many vowels are there before position 5? It's the number of vowels before position 4, right? Plus the number of vowels at position 4. Again, there's no vowel at position 4. We're really asking, okay, is this a vowel? It's not. So it should stay the same. The accumulator should stay the same, right? So that handles the repeat part. And then the next part is to think about when we want to stop, right? So we already said that we will definitely stop. Remember, the 0 was the first row, second column. This 0 was the first row, first column, the starting accumulator. The s dot length said potentially how long we would go in the item column, right? So we'd potentially go up to the s dot length minus 1, which is the position of the last character here in this string. But we actually stopped sooner, right? We stopped as soon as we counted the 5th vowel, right? So what is keeping track of the count of the number of vowels? It's the accumulator, right? So we want to stop when the accumulator is equal to, and in this case we don't always want to do 5, right? The 5 was the vowel number we're looking for. So we want to stop when the accumulator is n.